This is 2025 paper 2 question 6. We're given this trigonometric equation told to solve for a. So first of all, we need to get one answer. So one answer will be the sine inverse of a half, just by doing sine inverse on both sides. And when you do that, you'll get 30 degrees. Now, if we look at the unit circle, and if we look at 30 degrees, remember that sine is the y value. So this is the y value. So where else are we going to have that y value to find another solution? Well, if we go over here, this is the same y value along this line. And we can get to that point by rotating up by 30 degrees on the other side. So that kind of red angle here, this is 30 degrees. But then we always measure angles from the positive x-axis. So we need to figure out this. So 180 minus 30 will give us 150 degrees. So these are our two main answers, and then we can add or subtract 360 as necessary. So if we do it to 30 plus 360 will give us 390 degrees. Due to the 150, and we get 510 degrees. Now we don't want to add 360 again, because then it'll be too big. It'll be bigger than 720. So let's subtract 360 from these. So 30 minus 360 will give us minus 330 degrees. And then 150 minus 360 will give us minus 210 degrees. And there's our 6 answers. For part 2, we're given a function and we're asked to write the period and the range. So this is the absolute value of 4 sine x. So basically, normally sine, it goes up and then down, and then it continues down further, and then it comes back up, and it repeats every 2 pi. So normally, the period is 2 pi. But here, instead of going down and then it repeats over here, it's actually going to repeat half as quickly, because instead of going down, it just goes back up and it repeats like that. So the period is going to be half of what it normally is. So the period is going to be pi for this. And then in terms of the range, it helps if we just do it in steps. So if we start off with sine x, we know the range is between minus 1 and 1. Then if we multiply this by 4, because here we have 4 sine x. If we have 4 sine x, well then what we'd have is basically if we got minus 1 for sine x, then 4 times minus 1 will give us minus 4 is the smallest answer, and the biggest one is 4 for that reason. Then if we take the absolute value of that, so the absolute value of 4 sine x, well now the smallest it could be is 0, obviously, and the biggest it could be is still 4, and then what we do is we take that and we subtract 1 from it. So basically if we have 4 sine x, the absolute value of 4 sine x minus 1, well then the smallest value was 0, but now we're taking 1 away from that, so we'll get minus 1, and the biggest value is 4, but we're taking 1 away from that, we'll get 3, so minus 1, 3 is our range. In part C then, we're given a triangle and told to use the cosine rule to find tan of CBA. So here we have the cosine rule down here. So you can see our C value, cos A is what we're looking at, so A is the angle we're interested in, so this is our A in a sense, but it's called B for some reason, so it's kind of confusing. But basically, the important thing is that if this is the angle we're using, then the angle, you can see the corresponding side for angle A is the small a, so it's the side that's opposite of the angle. So if we're using an angle A, we have to use the side opposite that as this one, and then the other two, they're kind of symmetrical, it doesn't matter. So I suppose our A squared in this case is going to be 2, and we're going to have that squared. So we'll have 2 squared equals, and then we're going to have the other two sides, so we're just going to have 3 squared plus 4 squared minus 2, and then the product of the other two sides, and then cos of the angle opposite of the first side, which is 2. This is the angle we want. I'm just going to call it x. And then we can just solve for x. So we'll get minus 21 equals minus, and then that'll be 24 cos x, which means that cos x is equal to 21 over 24. Now, you could solve for x and then figure out what tan of x is, except you kind of can't because they want the answer in surd form. So what we're going to have to do is we're going to have to kind of calculate tan very accurately. So the way that we can do that is we can take this fact and we can use that to draw a right angle triangle. So we can have a right angle triangle. Let's say this is our angle x here. The adjacent side is 21 over the hypotenuse is 24. Let's figure out what this side is. Let's just call it y. So we know that 21 squared plus y squared will be equal to 24 squared. So y will be the square root of 24 squared minus 21 squared. You can put that into your calculator and you'll get 3 root 15. So y is 3 root 15. So we can easily figure out what is tan x by taking the opposite, which is 3 over root 50 or 3 root 15 over, and then obviously we have the adjacent, which is 21. And then we can simplify that because it says in the form root n over m. So you might think that we've gone somewhere wrong, but 3 over 21 is the same as 1 over 7. So we have root 15 over 7 as our final answer.